Hello, friends. Now we're going to talk about our sum and difference identities. And I'm not going to derive these for you. I'm just going to write them out. We have three trig functions, three basic trig functions, sine, cosine, and tangent. And we have a sum and difference, add and subtract identity for each of these. So I'm going to write this first identity out two ways, and I'm going to compress it into one identity. So we're going to look at sine sum. So this says that sine of sum u plus sum v, this can be written as sine of u cosine v plus cosine of u sine of v. So we have sine sum, and we can also have sine difference. And that would say that sine of u minus, so we have a difference symbol there, v. So sine of u minus v, the sine of some difference. That can be written as sine of u cosine v minus cosine u sine of v. So we're focused on this pattern, and I want you to notice the pattern is all the same. If we have a plus, we have a plus, and a minus, we have a minus. So rather than writing it out both ways every time, I'm going to say sine plus minus, plus minus. All right? So let me rephrase this. The first identity is the sine of some u plus or minus some v. The pattern for that is sine of u cosine of v plus minus cosine of u times sine of v. So we have two identities. The pluses, if you start with a plus, you are going to have a plus when you expand it. If you start with a minus, you'll have a minus when you expand it. So let's look at what cosine of u plus minus v looks like. So my pattern here, this is going to be cosine u times cosine v minus plus sine of u times sine of v. So notice if I start with a plus, when I expand it, there's a minus. And I start with a minus, expand it, and get a plus. Lastly, we have tangent of u plus or minus v. So my tangent property is tangent u plus minus tangent v over 1 minus plus time, or tangent u times tangent v. So plus, then we have a plus and a minus. Minus, then we would have a minus and a plus. All right, so we need to know these identities. Essentially, on a test, I would expect you to know and be able to recite, list on paper, your sine and cosine, sum and difference. Tangent, not so much, but definitely on a test, you would need to be able to use these, and I would not give you the formula. All right, so let's apply this, okay? So sum and difference identities, they can be used to help us find values for angles on the unit circle. We can find exact values without our calculator. So what does that mean? For this example, we're going to simplify using either a sum or difference identity for cosine. So we want to find an exact value for cosine of 75. Sure, you can type this right into your calculator. You'll get a decimal 0.258819041. Sure, cool. I want you to give me an exact value. So that decimal I gave you is not exact. So cosine 75, that is not something that I can find on my unit circle. On my unit circle, I know 30, 45, 60, 90, 135, etc. around the unit circle. I think I left 120 out in there, but we have all these values on the unit circle that we can find. And 75 doesn't fall on any of those predefined angles we like to deal with. Can I write cosine of 75 as a sum or a difference? And sure, you guys are probably all telling me, well, on the unit circle, this is the same as cosine of 30 plus 45. 30 plus 45, that works. Are there other values that we can use off the unit circle? How about 120 take away 45? Is that the same? Sure. We don't have to use bigger numbers than we need to, but it will still work. This will still give us the same answer as if I used 30 plus 45. So I'm going to do it that way. I'm going to use 30 and 45 just because that's easier. But cosine of, we have 30 plus 45. So this is cosine sum. And we think, okay, what's my cosine sum identity? I just learned it. Cosine of u plus v is cosine u cosine v minus sine u times sine v. So expanding this, I now have cosine 30, that's my u, 30, times cosine of 45. The symbol or the operation in between those two products is going to be minus, and then I'll have sine of 30 times sine of 45. Now, these are all values I know off my unit circle. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Minus sine of 30 is 1/2. And sine of 45 is root 2 over 2. Simplifying, I have root 6 over 4 minus root 2 over 4. Or more concisely, root 6 minus root 2 over 4. In my opinion, this is completely acceptable as your final answer, but I do want you to note that sometimes you may see something in your homework where they'll factor a GCF out. And if you notice right here, we have two terms that we're subtracting, and each of them is a product. We've got multiplication by root 2 over 2. So I could factor out root 2, and that would give me root 3 minus 1 over 4. And so sometimes I know that my math lab or your textbook will present an answer like that, and that's exactly the same. On a test, this is completely fine. And once you're working in my math lab, you'll see pretty easily how it wants you to present the answer, and so you'll know how to put that in. All right, so we did one example. We used a cosine sum identity. We could have used cosine difference, but we did this in degree mode. So let me do this one more time. We're going to do one more example, but we're going to simplify in radians. Let's find the exact value for sine of 7 pi over 12. Okay, well, this is in radians, and it's hard for us to process radians. What can we do with radians to simplify them or to make them easier for us to think about? Well, I can convert radians into degrees. The way we would do that would be to multiply by a unit fraction. 180 degrees is equal to 1 pi radian. The pi's cancel. I have 7 times 180 over 12, which simplifies to 105 degrees. So this is the same as sine of 105 degrees. So if you're presented with a problem in radians, just convert it to degrees. So now let's think about two values on the unit circle that I can either add or subtract to create 105. The easiest two values for me are 60 and 45. So this is the same as the sine of 60 degrees plus 45 degrees. All right, so now we have this sine of the sum of two arguments. So, or argument, I should say, is a sum. And we know our sine sum identity. Sine of u plus v equals sine u cosine v plus cosine u, running out of space, times sine of v. So this is the same as sine of 60 times cosine of 45 plus cosine of 60 times sine of 45. So we know these values. Sine of 60 degrees is root 3 over 2. Cosine of 45 is root 2 over 2 plus cosine of 60, 1/2, sine of 45 is root 2 over 2. So we can simplify this a little bit further. I've got root 6 over 4 plus root 2 over 4, or rather root 6 plus root 2 over 4. So that's the best way for us to present our answer, but of course we can factor a GCF out, so we could write this as root 2 times root 3 plus 1 over 4. So that's acceptable as well. And just to reiterate, this value we've calculated in the box, this is exact. This is exactly the value. All right, if I type sine of 105 into my calculator in degree mode, my calculator is going to give me a decimal that I have to round. Even though you're saying, oh, well, Miss Stein, it is so precise down to this last, what is that, the 9th digit there? 96592588263, the 10th digit past 0. Well, the truth is, those digits keep going. So when you write this on your paper, the calculator has rounded it and truncated it for you. So this is an approximate value. I don't want the approximate value. I want the exact value. Okay? Now you could check it. You could type sine of 103 in your calculator in degree mode. And you could type this expression in your calculator and they should be equal. They should both give you this exact, well, exactly the same approximate decimal value. So I hope that helps you understand how the sine and cosine sum and difference identities can be used and can be helpful. Sometimes we'll see them while we're solving. We will see them in proofs. Moving into Calc 1 and Calc 2 and Calc 3, you might see these trig identities hiding inside problems. So you want to be familiar with them and know how to recall or utilize them. All right, have fun, be safe, do good. You're on your own. No, just email me if you have any questions. Bye.